Because of the amount of bits, the numerous amount of bits that are being manufactured by bit contractors and bit producers, every drilling engineer needs to ensure that he or she has selected the right bit to drill his well, to ensure that not just to drill the well, but the bit is optimally chosen and delivers the well as it should. Because a lot of bits are being manufactured, we see a lot of names with a lot of bits with a lot of names with a lot of features. IADC has gone ahead to reclassify these bits into large chunks. That once we look at once we look at the basic classification of the way this bit has been classified, we can actually tell if this bit is suitable for the well we want to drill. So, in today's topic, we will be speaking on roller cone bits and how IADC, that's the International Association for Drilling Contractors, have gone ahead to reclassify these bits and made it very easy for us to be able to pick up, to be able to determine and to be able to determine if this bit will be suitable for the job we want to do and will optimally be able to drill our wells. So, jumping right straight into it, the course outline will be as follows. We'll be looking at the IADC nomenclature. We will be speaking about mill-tooth bits. I mean, the first classification of these bits using the numbers. Then we'll be looking at the TCI bits. That's the tungsten carbide, the bits with tungsten carbide insert. Then we'll be looking at how their bearing and gauge. The features of the bearing the features of the bearing and gauge are classified. Then we'll be looking at the special features. If the bit has any, then we'll go ahead to take examples. So, looking at this number here, 117A, this is what the typical IADC classification will look like for a roller cone bit. Now, the first number, moving from the left to right, the first number one, tells you, now this is just an example, 117A, but that first number tells you of the cutting structure of the bit, ranging from, it could be 1 and it can go all the way to 8. Now, what does this number mean? This number 1 to 8 actually means what kind of bit, what kind of roller cone bit it is it. So 1 to 3, once you see numbers 1 to 3, it tells you immediately that this is a mill tooth bit. And once you see any number ranging from 4 to 8, immediately tells you that this is a bit with tungsten carbide insert. So as easy as it. 1 to 3, a mill tooth bit. 4 to 8, a TCI bit. Looking at the number in the middle, that's the next number, but this is moving from left to right. Tells you from 1 to 4. That tells you the cutting structure type. And when we say cutting structure type, it tells you how that cutting structure has been designed because of the hardness of the formation. So going from 1 to, it ranges actually from 1 to 4. And from 1 to 4 tells you 1 being the softest formation, then 4 being the hardest formation. So as you move from 1 to 4, it goes from from very soft to semi-hard to very hard. So that's what that second number says. Then looking at the next number 7, again, this is an example, but it ranges from 1 to 7. So it tells you what kind of bit is it. Is it an air cooled bit? Sorry, not bit, bearing. Is it an air cooled bearing? Is it a friction bearing? Is it a roller bearing? Is it gauge protected? Is it sealed? Etc. That's what that number will tell us. Then the last alphabet, I have it in red because it's special feature. And not all bits have special features. So in the event you see the IADC number of any bit of a roller cone bit come out this way with an alphabet at the end, it tells you exactly what special feature that bit has. Is it air cooled? This particular alphabet here is air cooled. Could it be that that bit is air cooled? Could it be that it has a center jet that you will see a C? Could it be that it's used for motor applications? You see, and could it be that it's used for deflection? You see a J there. So we'll go into details as we move in the next few slides. So looking at this slide here, this is straight up how a mill tooth bit will be classified. So looking at the numbers, let me just put up my cursor quickly, just 1 minute. The pointer options, laser pointer, yeah. So look here, you see 1. 1 tells you, as in this series, tells you that this is 1 and 2 and 3, and there will definitely be, and this here immediately tells you, ladies and gentlemen, that this is a mill tooth bit classification, or the mill tooth bit category. Then moving to the next column, you see one, two, three, four. So moving from soft to hard. That's for this particular bit here, for this particular mill tooth bit here. One. It goes again from one to four, goes again from one to four. So let's take a quick zoom on what this bit will look like. So if you look at a bit that might be classified 1-1, clearly you see that it's a milled tooth bit. That's the cutters are made from the bit, it's milled. And I want us to pay very close attention to the cutters. You see that the cutters are pointed, they are long and pointed, very, very efficient for excavating very soft formation. Look closer to the next bit below. You see again, it's milled from the bit, but this time the cutters are not as long as this first one, as the 1-1 here. So it's still milled out, but it's shorter. And if you look further down for series 2, you see that again the cutters further reduce, become shorter. So rule of thumb, as we go from soft formation to very hard formation, the cutters are made shorter, so it's easy for them. So not so because when you if it's that long and it goes into hard formation, the propensity that it will get in and break off is very high. So the shorter the cutters, the more efficient it is to use to cut a very hard formation. So the next classification here is for TCI bits. That's the tungsten carbide inside bits. And as you can see, they are classified from 4 to 8. And looking at the next column beside it, again, it goes from 1 to 4. So this bit, I think they're normally called button bits because when you look at the insert, they look like buttons. Now, again, the same rule applies. You have soft formation moving all the way to hard formation. So as you move from soft to hard formation, the cutters go from very long cutters to very short cutters, or rather what will look more like buttons. So if you look at these two examples here, look at the 4-1 bits, you see that the inserts there are long and kind of protruding. But when you look at the cutters that are on this bit, on this 8-3 bit, they are short and look like buttons and well built for tougher and harder formations. So, what are the bearing or gauge classifications that we can have on these bits? Now, when you see one at as in the third number, when you see one, it tells you it's a standard roller bearing bit. You see two, it tells you a roller bearing bit that's air cooled. You see three, it tells you that it's a roller bearing bit that's gauge protected. You see four, it tells you that it's a sealed roller bearing bit. So it's not just that is it a roller bearing, but it's sealed. And when you see 5, it tells you that it's a sealed roller bearing that has gauge protection. And when you see 6, it clearly tells you that it's no longer, we've moved away from the era of the roller bearings. We've now gone into journal friction bearings. We'll be discussing the advantages and disadvantages of some of these bearings as we move into other modules. When you see 7, it's not just telling you that it's a sealed journal of friction bearing, but it's telling you also that it has gauge protection. Then when you see 8, it's telling you that it's built for directional work. 9, special applications. So that's what that third number signifies. So when you see, for example, a 137, it tells you that, okay, this is a mill tooth bit moving from very hard formation, and that 7 at the end tells you that it's a sealed friction bearing bit with gauge protection. So as easy as that, easy peasy. Then if there are any alphabets at the end of that bit, it tells you immediately that this bit is built with a special feature. So you want this is built for that application where you want to use it. Say you want to use it for deflection, for jet deflection, you should be looking for a bit that has J at the end. You want with special log pads, you should be looking for a bit that has an L. For motor application bits, for air drilling application, A. For special bearing seals, B. For that has a center jet, C. So on and so forth, all the way from A all the way down to Z here. So whatever bit, if you see that alphabet at the end, it tells you immediately from top of your head that, hey, this bit has this special feature. You might want to consider it if you are thinking of that kind of application for the world that you want to drill. So finally, to be sure that we all understand these bits and how we select them, I have a few examples for us here to look at. I want us to want us to look at it for a few seconds before I try to answer. So, for a 547 A, your answer is very correct. It's a TCI bit. It's a 5 going for medium formation of high compressive strength. That's what the 4 is for. Then seal bearing with gauge protection. That's what the 7 is for. And A for air drilling, or the bearing is being lubricated by air. The next one is the 117. Once again, you are correct. It's Biltooth bit for very soft formation and has seal journal bearing with gauge protection. Next, we have the MTB. That's the 134. Again, it's a Miltooth bit for medium hard formation and has sealed roller bearing. That's what the 4 is for. It has those special features, so that's why you don't see any alphabets. The next one is the 412. Again, your answer is correct. It's a carbide insert bit. That's what the 4 is for. For soft formation, you can see 1 there. And 2, it's telling us again that it's air lubricated or air cooled. Then finally, a 326. Again, your answer is very correct. So it's a Miltooth bit. That's the last range of the Miltooth bits, the 3. And it's for 2 tells us it's a semi-soft formation moving to hard, because you have 1, 2, 3, 4. So moving from 1 to 2. Then 6 tells you that it has a sealed friction bearing. The bearings are sealed. The friction it has friction bearings but are sealed. Then this particular bit is designed for motor application. So thank you very much, everyone, for watching this video to the end. We hope you enjoyed. We hope we've been able to pass some lessons across. We would appreciate if you go ahead to pass your comments and make your suggestions, and most especially like, subscribe, and turn on the notification button. We have our social media, other social media platforms. We're on LinkedIn, we're on YouTube, where you currently are, and we're on X, and we're also on Instagram. So please go there, watch our videos, and we will expect to see you in the next lesson. Thank you very much once again for watching, and bye for now.